Hello Bio 2, this is Mr. B, and we are starting our last chapter today with our mammals. So this is our last group of animals, the only one we haven't talked about so far. And so our mammals, big characteristic is what we are actually mammals, so hopefully we might know kind of we have hair and produce milk is going to be our two things that make a mammal a mammal. So to start with our first section is just introduction to the mammals. And so to start, we obviously have to get what are the characteristics of mammals, which I've kind of alluded to a little bit already. So all mammals have two notable features. So this is the most important, these are the two most important features that all mammals have. They all have hair, and they all have mammary glands. And in females, the mammary glands are produce milk to nourish the young. So this is our kind of our most important, all-inclusive characteristic of mammals, that they have hair and they produce they have mammary glands, and in the females it produces milk. So this is the most important thing we're going to need to know about our mammals. And in addition to having hair and the ability to nourish their young with milk, all mammals breathe air. So none of them can use gills to carry out their respiration. They all have to breathe air. They have 4-chambered hearts, and they are endotherms, which you remember they can generate their own body heat internally. So these are other three characteristics that all mammals have in common, but the first two are kind of the most important ones, the most distinguishing ones that no other really groups have. And so now we're going to have to look at again the history of mammals. So when did they first come around? When did we first see them? So mammalian fossils are characterized, so we classify them by a lower jaw with a large teeth-bearing bone connected directly to the skull by a joint, and distinctive features of the limbs and the backbone. So the reason we can tell mammal fossils apart from kind of the rest of them and when they lived is by looking at their jaw. And we can see what kind of teeth they have, what the shapes were, and that can tell us what time they lived, it can tell us what size they were, it can tell us what kind of food they were eating. So looking at the fossil of the lower jaw of the mammal is a good way to tell us kind of to classify them. And mammals are actually descended from ancient reptiles. So that's where our first kind of our evolutionary origins came from, was a group of reptiles split off and became the mammals. And ancestors of our modern mammals today, they diverged from the ancient reptiles during the Carboniferous period. So our first mammals were around during the Carboniferous period. However, they were very small during this time. They weren't very prevalent, because this was the time when like amphibians and insects kind of ruled the world, and actually coming in to kind of giving rise to the dinosaurs. So, however, for millions of years, though, our various mammal-like reptiles lived alongside other reptile groups. So during this Carboniferous period, they were living kind of in harmony with our other reptile groups because there weren't any giants dominating the earth at that time. So our first true mammals, so ones that would resemble the ones we have today, appeared during the late Triassic period, which is about 220 million years ago, is when our first kind of like common mammal would appear. And these mammals were very small and probably nocturnal, and that's because they had to stay out of the way of the dinosaurs. If they were large, the dinosaurs would just pick them off. They'd be an easy food source. So they were small, they had to stay underground, and they had to come out at night in order to survive. However, after the extinction of the dinosaurs, mammals underwent an adaptive radiation. So this is a term we're talking about in biology right now, which is just kind of basically like a big explosion is what it is. A big explosion of mammals, because there was really no other animals at that time for them to compete with. And so because there was no other animals for them to compete with, they increased in size and they occupied many new niches. So a niche is just a certain place, like a job description in the environment. So a certain job that they could fill in the environment. And so the Cenozoic era, which is when they came to be, is now called the Age of the Mammals, because that's really when they took over. And so that's kind of our history of our mammals, briefly how they came to be. So now we actually have to look at the form and function. So again, all of the different capabilities that they have to survive. And so the mammalian body has adapted in varied ways to a great many habitats. So mammals live in places all over the earth. So our first one is obviously body temperature control. So mammals are endotherms, just like birds. And so they also have a high rate of metabolism, which helps us generate our body heat. And the mammals also have external body hair that helps them keep warm. So we all have hair. All other mammals have hair as well. And then also they have a layer of what's called subcutaneous fat. So I want you to be able to pronounce this word. It's actually subcutaneous. And just sub means below, and so it's a layer of fat that's located beneath the skin. And also this has helped to conserve our body heat as well. So all mammals, their high metabolism helps us generate heat, hair helps us keep warm, and this layer of fat helps us conserve body heat as well. And also, kind of to go along the opposite of that, is that many mammals have sweat glands that help cool the body. So in order, we also have to keep warm, we also have to cool down. So if our body temperature gets too high, a mammal sweats. And then the evaporation of the sweat is what cools the body. And then some mammals actually pant to cool down. So dogs are kind of the obvious one we see doing that. And we might actually do that well when we have strenuous exercise. We pant, that's also to kind of help pull in more oxygen, but also could be to help cool down our body as well. And so a big thing with mammals, since they control their own body heat, is they have to maintain what's called homeostasis, which is, again, just like, hopefully this is a review term, which is having a nice internal balance, everything staying, working properly. And so the ability of mammals to regulate their body heat, again with warming up and cooling down from within, is an example of how they can maintain homeostasis. So that is it for our first part of mammals. Let me know if you have any questions.